So sir is currently working as an assistant professor in the Department of Computer Science and Engineering at NIT Warangal. He has awarded PhD degree from Department of CSE, NIT Durgapur. He has more than 20 years of rich experience in teaching, along with 11 years of experience in research in the quality educational sector. He has authored over 70 papers in the referred journals and conferences and scored more than 1800 citations. Sir has research publications in prestigious journals like Applied Soft Computing, Neural Computing and Applications, International Journal of Fuzzy Systems, Journal of Ambient Intelligence and Humanized Computing, Soft Computing, Journal of Intelligent and Fuzzy Systems, Engineering Applications of Artificial Intelligence, and many more. He is working as an active reviewer in many reputed journals and conferences. He is also a program committee member of several international conferences. He has received 3 conference-based paper awards in CSO 2014 Beijing, FICTA 2015 Durgapur, and Forbes 2018 Kolkata. Sir is a well-known resource person in the universal human values field, which is required to nurture the human minds to bring feelings of happiness in ourselves, our family members, and our society from a larger perspective. He has delivered several talks in many faculty development programs and seminars. Moreover, he has chaired many sessions at prestigious conferences and delivered talks as an invited speaker in many FDPs, seminars, and conferences. So, 2 students have completed their PhD under Sir's guidance, and 5 more students are doing their PhD under his supervision. Moreover, Sir has supervised 1 postdoc fellow at NIT Warangal. The prestigious IEEE Society designated Dr. Das as a senior member of the IEEE. He is a senior member of ORSI and a member of ACM. Sir's research interests include soft computing, artificial intelligence, evolutionary computation, machine learning, and multi-criteria decision making. So, with this short introduction, I request Dr. Sujit Das sir to deliver the inaugural session on Introduction to Artificial Intelligence. Over to you, sir.
So, thank you, madam. Thanks for this nice and brief introduction. So, really, it's a privilege for me to be a part of this first talk immediately after this inaugural session. And since this FDP is all about artificial intelligence, and the topic is, I think, a very emerging topic, AI-based problem-solving techniques. So really, it's a very much important topic in today's scenario. And again, I feel grateful to the coordinators of this FDP so that they have given me a chance to share my thoughts, particularly in the very first session, where I'll communicate that, as Madam suggested, and artificial intelligence and brief introduction, so that in the remaining sessions, our participants may be, they will be a little bit comfortable with these various fundamental topics of artificial intelligence. So once again, I convey my sincere thanks to the coordinators from St. Peter's Engineering College, Hyderabad, as well as my colleague, actually, Dr. Manjuwala Visi Madam from Department of Computer Science and Engineering, NIT Warangal, for their kind invitation. So now participants, so feel free to ask me any questions if you have during my sessions also. You can note down your questions. You can ask me at the end of the sessions. Now I will share my PPT. Now one thing, so since it's an online mode session, so I will request my participants. So if you feel that sometimes I am not audible or my slides are not moving, please immediately convey the message to your coordinator so that immediately they can contact with me and I can do the necessary things. And during my sessions, to avoid any distractions, I will switch off my video. Once again, obviously, we'll switch it on after the end of this session. Now I'm slowly moving towards my session. I will share my PPT. So I have shared my PPT. Can anyone confirm, please? Is it visible or not?
Yes, sir, it is visible, sir.
Okay. Thank you, madam. So this is all about brief introduction of artificial intelligence. Just give me just 1 minute time. Just 1 minute, please. Then I will start. Okay. Okay. So this is, as I was telling, so in this session, we will discuss some fundamentals of artificial intelligence. So now, very first question on artificial intelligence. So I think here, see, it is having two keywords. One is artificial, second one is intelligence. So obviously, then we should know that what is artificial and what is intelligence actually. So now, what is artificial and what is intelligence? Normally, we say that, okay, something is man-made, maybe something's natural. So obviously, once you will say something man-made, so that belongs to the artificial kind of things. So artificial means obviously something which is man-made. That means which human beings have developed, which is inspired by the thought process of human beings. And another keyword that I mentioned, intelligence. Now, what is intelligence? No need to mention that intelligence means that is basically thinking power. How much efficient we are, how much comfortable we are in the thinking process. So then, if we combine these two, so this will lead to that AI means a man-made thinking power. So obviously, all the human beings, we have inherent with us some thinking power. We can visualize something. We can perceive the environment. We can visualize the environment. Okay, then based on that, we can start our thought process. And based on our thought process, based on our experience, ultimately we take some decisions that, okay, what we can do or how we can respond towards the environment. What is the environment? Once you are human being operating, suppose today, right now, maybe I'm not in department, maybe I'm now some another place. So from which place actually I'm delivering the talk, or from which place my participants are participating towards this FDP. So that is the environment. So where an AI agent, so if we feel that myself actually or your coordinators are particularly AI agent, so in where actually AI agents are interacting, where AI agents are delivering, where AI agents are simply operating. So simply those environment, that particular things we say as an environment. So as I was telling, so that artificial intelligence means, so this is a particularly man-made thinking power. So that means here we want to actually, that some systems or some machines are there. That means we want to include the thinking power in the machines. We want that machines also should think in similar manner, whatever a human being can do. See, once I'm thinking that particular concept, okay, we want to incorporate the thinking power to a particular machine. So, okay, I can think, I can guess it quite easily. But ultimately, the process, how to make a system efficient so that it can start thinking, it can start doing the things like a human being. It is not that much easier. So what are the various backgrounds? What are the various concepts that you need to know so that we should be familiar with the various process that a machine also can start thinking. So that is the discussion topic of this today's session. Okay, so this is a formal definition of AI, whatever I have written here. So it is a branch of computer science. So I should not say it is a branch of computer science, actually artificial intelligence. So that is very much, I think, what should say, very much overlapped actually with various disciplines. So, as you have seen in the inaugural session, some of our, I think that members was telling that now without artificial intelligence, even we cannot think in any of the disciplines or any of the work, whatever we are doing in our real life. So it is a branch of computer science, formally I need to say, but officially I should not say, by which we can create intelligent machines, which can behave like a human, think like a human, and also can able to make decisions. See, these three keywords are very much important. We want some intelligent machine that should behave like a human, that should think like a human, as well as they need to take some decisions like a human being. So how to do that? So only that is our discussion topic today. Not only today, I think that your coordinators as well organized that whatever the sessions are going to come, once the entire FDP will be over, obviously our participants will be very much efficient on all those concepts. Forget the name, John McCarthy, 1952 most probably. John McCarthy, that we say, the father of AI, father of artificial intelligence. Okay, what now see, that time, how sir defined the artificial intelligence? What sir has told regarding artificial intelligence. So according to Sir John McCarthy, the science and engineering of making intelligent machines, spatially intelligent computers, that is the artificial intelligence. So I hope now, right at that point, you are getting that artificial intelligence means, so here we want to make our main motto, main objective is that we want to make our systems, our machines intelligent. So that is our ultimate objective. Now, what to do to achieve that objective? So obviously, so that should be our discussion topic of this session as well as this FDP. Okay, now let us see. So as I was telling, we want to implement the thinking process. We want to implement thinking process. We want to implement decision-making process in a particular machines. So how we should do that? So I think before getting to the concept that how we can include thinking process, how include reasoning ability, how we can include decision-making power to a particular machine, before that we should know something. Before that we should know about us, okay, that how a human being start thinking, how our human brain is working, how our human brain is thinking, how the human being is learning, how the human being is taking some decisions based on the experience, how we are behaving once we are trying to solving some problems. So if we have a close look in our brain, our brain, as you know, composed of number of neurons actually. So all these things are getting place in the neurons only. So today I'll not coming to that part. But here main thing is that we should be very much, I think, very much familiar about the fact how human brain can think, how human brain can decide, how human brain can be experienced, how human brain can learn something. So if have a deeper knowledge, if we have a deep knowledge on that particular process, only then we can think, yes, so similar thing we can try to implement in a particular machine, not before that. Are you getting the fact? So that means, so we should have a very much close look. We should have a detailed study regarding our human brain structure. Only then it should be fruitful, maybe fruitful to implement AI-enabled machine, not before that. So why artificial intelligence? Why it is important? I think this is needless to say why we need to study the concept of artificial intelligence. With the help of artificial intelligence, what we can do now, everyone we know. I think large language modeling kind of things, or maybe by the blessings of artificial intelligence, now we are having much more advanced version of artificial intelligence. Maybe that is explainable AI, maybe that is generative AI. So where we can do so many things simply, where the things were unbelievable. Believe me, itself, a few 1 decade back, we cannot think about that. But right now, that is a fact. That is not a virtual thing. That is a fact, and we are living with this artificial intelligence only. And that now in that that in the area of big data, that in the area of data science particularly, I should tell that all the giant industries, as all they are providing their help, all they are providing their guidance through some virtual assistant. I think all we are very much familiar regarding the virtual assistant. If you want to start chatting with some giant industries, or if you want to start talking, you will find out, you will say, all these are getting, whatever you are getting, that is virtual assistant only, personal virtual assistant only. No one is talking behind that. Obviously, after some time, some expert may be there for helping you. But in the starting or initial phase, no one will be there. All systems are taking care of that. So can you imagine how systems are taking care of that? So obviously, all those are due to the blessings of this artificial intelligence. And mainly in some places we need to adapt this artificial intelligence, so it is much more fruitful. Here, there may be some environment, there may be some phenomena where simply it may be very much risky for a human being to operate. Maybe in the case of fire, maybe the case of severe flood, maybe the case of severe earthquake. So some natural calamity where simply human is very much unfortunate to help others. So there easily we can employ, or we can install the robots or AI-enabled machines so to do our tasks. So obviously that is another blessings of artificial intelligence, by which we can save a number of lives where it could have been impossible if AI was not there. So I like that many things are there. So slowly we'll be coming to the point. Now, what is the goal of artificial intelligence? So firstly, I should tell main goal of artificial intelligence is to create expert systems. Now, what is expert systems? Obviously, expert systems are expert enough. So expert means what? So obviously, they should exhibit intelligent behavior. They should exhibit the learning process. They should be familiar with the demonstration. They should have the explanation capability, and they should have the capability to suggest others or to advise its users. Only then we can tell a system is expert system. So obviously, once you are going to create a system, AI-enabled system, we want to incorporate all human kind of activities, the power of human brain to a particular machine. Obviously, we need to create some expert systems, which the system will be expert, and it will help us in that expertise manner. Second objective, again, I'm repeating, to implement human intelligence in machines. So I am repeating it many times so that main objective of artificial intelligence will be very much clear. It is nothing but we want to implement human intelligence in machine so that machine also can understand, machine also can think, machine also can learn, and machine also can behave very much similar like a human being like us only. Now, very much important question. If we say that what are the various components of artificial intelligence, or what comprises to artificial intelligence? So again, I think not to say artificial intelligence is very closely related. So I would not to say closely related. Again, I should say that we cannot imagine computer science without artificial intelligence. We cannot imagine neuron science with artificial intelligence, biology with artificial intelligence. Can you imagine mathematics without the power of AI? No. Can you imagine sociology without the power of AI? Simply we can say no. Now see here how AI is closely related to our various domains. Now at this moment, maybe of my participants, maybe they have some questions. Sir, you are telling only about artificial intelligence. So what is the fault of machine learning and deep learning? Okay, so actually this session is all about artificial intelligence. So I am focusing only on that. But again, I should say that this artificial intelligence, so this machine learning, I should say, if this is the machine learning, then I should say that machine learning is a subset of this artificial intelligence. Machine learning is a subset of this artificial intelligence. And ultimately, deep learning, we should say, that is a subset of this machine learning. So there is some important difference that, as I was telling, that machine learning, artificial intelligence. Yes, so there is a very much important difference. Sometimes we may forget, okay, we feel that what is AI? That is the machine learning. What is machine learning? That is deep learning. So at the end, I should focus on that. Right now, I'll not do any comments which will make some confusion among us. Let us first understand AI in much more better manner. Obviously, then we can come to the concept of machine learning and deep learning, and we can find out exactly what is the difference between artificial intelligence, machine learning, and deep learning. As I was telling that artificial intelligence, it is the mother of everything actually. Machine learning, I can say, this is a subset of artificial intelligence, subpart of artificial intelligence. That means if you are expert in artificial intelligence, obviously you can tell that you are an expert of machine learning and you are an expert of deep learning. Now, what is advantages and disadvantages of artificial intelligence? You know, once something will have some advantage, at the same time, we will feel some disadvantage also. Everything should be there, coincide parallelly, but obviously we should take the advantage irrespective of the disadvantages of artificial intelligence. Here I can tell you something. So artificial intelligence advantages is that it is highly accurate and less errors. Now see, few things are there: high speed, high reliability, useful for risky areas, digital assistant, useful for public utility. I will explain each and everything. So see, what are the disadvantages of artificial intelligence? I am writing it is high cost. I am writing it cannot think out of the box, no feelings and emotions, increased dependency on machines, no original creativity. Now let us discuss actually. High accuracy with less errors. How it may work with high accuracy and less errors. So you know that AI system, so once we are developing some AI systems and we are giving them some tasks where some repetitions are there. Similar thing, if I ask a human being to repeat, to continue 100 times, what will happen? Maybe probably first 50, 60, 70 times, it may be more accurate. But what about after 80, 90, 100 times? Obviously, there will be by mistakes. If intentionally or unintentionally, willingly or unwillingly, whatever you may say, but you cannot avoid mistakes if we ask one human being to perform a repetitive kind of things which is repetitive in nature. But if you give the same task to an AI-enabled machine, then what it will do? Obviously, it can complete all the repetitive kind of works with very less error, with much more accuracy actually. And at the same time, you know that how much speed. You know, recently, you know, Google has developed a chip. Maybe you have heard about it. That how much actually that is a great invention from Google. Sundar Pichai a few days back have announced that, that how much powerful is the chief. I think you may have studied regarding that. And as I was mentioning earlier, that it is very much useful for the risky areas. So once again, I will not repeat it, but obviously once something we will find very much risky for human being, better to employ AI-enabled machines there. Okay, now let us again. So what is the usefulness of artificial intelligence in terms of public utility? So, maybe after 5 to 10 years, sometimes will come. Maybe your coordinators, Manjubala madam, sitting in his cabin. Okay, suppose Manjubala madam wants to move maybe to her apartment actually. So immediately what she will do? Maybe she may press a button, and the car will come to her cabin only. Her cabin is very much near to my cabin. So if her car comes, then also I can go with the car. Anyway, so car immediately, madam, pressing a button, immediately the car, no, nothing is there, no driver is there. Car is coming to madam's cabin. And madam is pressing another button, madam is okay, getting inside the car, and the car is starting its journey, and madam is going to automatically, that will drop madam in her apartment. Now see how powerful nature it is. No need to think anything. Madam may be doing some research work, so I'm traveling in the car. Now see how much powerful it is. Self-driving car, that is not a joke. That is a reality today. So another thing is that facial recognition for security purpose, today. So obviously once we are having all the blessings of AI, data science, machine learning, at the same time, some cards, something is there also on the other side. But how to come out from that? Obviously, the face recognition, that is another important, very crucial recognition or very crucial contribution of these AI-enabled systems. Whatever may be the crowd, you can imagine in Mumbai, basically in local trains, how much crowds are there. Suppose you want to identify some criminals in maybe Bandra or some Mumbai, some railway stations. Then what it will do? Maybe some closed circuit cameras or sensors will be installed there. And maybe suppose that person is traveling by the station. We have some hidden fact. Okay, that person will travel to Bandra station at the same time. Then simply our AI-enabled cameras or sensors, by the help of this face recognition capability, they can easily identify that person, and we will get to know, yes, that person is there in that place, and easily our security personnel can catch that particular person. So now you can feel that how we can use this face recognition for this security purpose actually. Many other advantages are there, better not to come. So directly I'll come. What is the disadvantages of artificial intelligence machines or AI-enabled systems? Obviously, high costs are there. It is not easy to develop these AI-enabled systems. So obviously, you need to spend more amount of money. Only then that may be fruitful to meet our requirements actually. Unfortunately, another thing is there, that is, it is cannot think out of the box. If you are employing a robot, okay, for some surgery purpose, obviously you cannot ask the same robot to do some operations once there is an earthquake or there is a natural calamity, is like that, maybe it's a flood. Can you ask that robot? Will the robot respond in similar manner? No. They cannot think out of the box. For what purpose you have developed, only that purpose they will respond. So actually now research works are going on that how to improve the capacity of AI-enabled systems. But anyway, so simple fact is that for which purpose we have trained the system, only that purpose they will work, other purpose they may not work. No feelings and emotions in AI-enabled systems. And if maybe you have seen in some of the movies that if you add some emotions to some robots, then how much response will be to the society. So that is I think, very much fatal kind of things. We should take much more care before incorporating the feelings or emotion kind of things in a particular AI-enabled systems. Sometimes it may be very much dangerous to the society. But obviously, a lot more research are going on that how to implement ethically. Actually, we don't want to do anything unethically. So we want to apply emotions. We want to apply feelings in AI systems. where obviously by maintaining the rules and regulations, by maintaining the law, and at the same time by maintaining the ethics. Ultimately, what it is doing, it is making us, we are now very much dependent on the machines. If I ask, if anyone asks something, sir, please, I went to the market, now I have spent some amount. So what is the total amount that I have spent? Maybe calculation is very easy. Some additions maybe of some numbers. But again, I will take help of my mobile calculator to do that. Manually, I will not do that. See, so slowly you are losing our creativity. Slowly we are losing our power actually. We are making systems, we are trying to get put more power on the systems, more creating ability on the systems. And what the systems will do, systems in turn returning us that, okay, you the human should have less power, with the machine should have some more power. So this is the applications of artificial intelligence. So many things are there. So here I will not touch that part. Slowly I will try to avoid all these things, that healthcare, transport, agricultural, education, e-commerce. Probably we can say that nothing is there where there is no application of artificial intelligence. In each and every corner, in each and every applications, whatever it may be, we will find out the blessings of artificial intelligence will be there. Now let us come to the fact. Slowly we are moving to the deeper of this AI. So we are writing a program with AI. And secondly, I am writing a program without AI. So where is the difference? Once you are writing a program without AI, that obviously that can answer some specific question, what it is mean to solve. But once I am writing a program for AI, a computer program with artificial intelligence, so that can answer a generic question also it is meant to solve. You're getting the fact. So if you are writing a program where AI is not enabled, obviously that will answer, that will reply to some specific questions. But once you are writing a AI-enabled program, obviously, so it will be much more generic in nature in comparison with this program without AI. And so once you want to do some modifications, you want to do some upgradations in the program, wherever you are not including artificial intelligence, so that means if you want to do some modifications, updation, then it will lead to change the entire structure of your program. But what is the facility for AI for program with artificial intelligence? So here, once you are writing program, AI-enabled program, so that can easily absorb new modifications, new updations. Okay, so nothing to do. So it has the power so that it can easily digest whatever the modifications you are trying to do, whatever the update you are trying to do. So what it is doing, simply it is putting some independent modules or independent piece of information all together without changing the entire program structure. So that is the powerfulness of modifications program where you are not incorporating AI is very much is not quick and easy. But obviously, once you are writing a program with the help of artificial intelligence, and if you want to do some modifications, it may be much more easier. Now, say deeper understanding what is intelligence. Two things are there. One is the intelligence, second one is the learning. So do you feel intelligence and learning are similar, or what do you feel? Intelligence and learning are different. When I should say that I have learned something, can anyone tell when I should say I have learned something? If by learning the fact some changes are there with me, I can upgrade myself, then only I should say that learning process has been completed with me. I think all of my participants maybe will be agree with me. What is learning? What do you mean by learning? Often we say machine learning. What do you mean by learning? So as I was telling, learning means in simplest sense, I have learned something. If I can feel some changes or something improvement with me by learning that particular thing, only then I should say that learning process has been completed with me. Learning is not simply learning. Okay, learning means by the help of learning, okay, some changes should be reflected. Only then we can say that is a learning. once children's, I think some kids, small ages, so we are incorporating learning process to them. And we will find out surprisingly, some improvement will be there on them. That is the learning. So today we are trying to understand at the introduction to artificial intelligence. So, okay, the learning process will be completed if immediately after this session we will feel that no, today we have something more. Whatever the knowledge with us before the session and after the session, we have enriched the knowledge base. If you have the feelings, then only you have learned something. So learning you are getting. What is learning? Now, what is intelligence? I should not say what is intelligence now. Intelligence is all about, as you know, all about the ability actually. It is all about the ability, this ability of a system to calculate, reason, perceive relationship, all these things, learn from experience, store and retrieve information, solve problems, comprehend complex ideas, classify all these things. So if you have all these capabilities, then only I can tell a human being may be intelligent, or maybe I can tell that AI-enabled system is intelligent. Are you getting the fact? So intelligence and learning, so these two things are entirely different. Intelligence means it is the ability. Okay, so it is the ability to learn, and learning means it is the process to improve yourself. Simply, that is the difference between intelligence and learning, we should say. So now, what is the actually various component of this learning? So if we see, obviously the learning, this intelligent is intangible. Can you touch it? You cannot touch. Now, whatever is that we can feel, we can sense only. So intelligence, so this is composed of few things. One is reasoning, second one is learning. Obviously, learning, it is a part of this intelligence. Problem solving, perceptions, and finally, this is all about this linguistic intelligence. Now, what is reasoning actually? So this is the intelligence, as I was telling, composed of these five major things: reasoning, learning, perception, problem solving, and this linguistic intelligence. Once again, so reasoning, once you are discussing the concept of reasoning, I should say that two different kinds of reasonings are there. One is the inductive reasoning, and what is deductive reasoning, let's see. So what is inductive reasoning? So inductive reasoning means it conducts specific observations to make a broad general statements. So we'll start with a simple simple facts. So if we can have some general statement, if we can make based on the simple, then only we will say that is the inductive reasoning actually. See what I am telling. Inductive reasoning. So from the specific observations, we want to conclude a general observations. Initially, we have some specific observations. By combining or by inferencing all those specific observations, we want to conclude one general observations. That we say, so that is the inductive reasoning. And what is deductive reasoning? Deductive reasoning is just the opposite one. Deductive reasoning. So it starts with the general statement. So we have some general sense, we have some general knowledge. Can you divide, can you subgroup your general knowledge into some fundamental ideas, into some pieces of facts or informations? If you can do that, then obviously that is called deductive reasoning. So deductive, so it will start with the general statement, and ultimately from the general statement, we'll try to come to some, we'll try to do to some specific observations or specific statement. So that is the deductive reasoning. So say inductive, what is the example? Just check. If I say Nita is a teacher, all teachers are studious. Obviously, see, initially I have two statements. Nita is a teacher, all teachers are studious. I have two specific observations. So if we combine these two observations, we will get Nita is studious. So that is, we are getting by applying inductive reasoning. Now again, in deductive reasoning, what you will get? See, if I say that all women of age above 60 years are grandmothers, see, so this is a general statement. Shalini is 65 years, therefore Shalini is grandmother. Now see, So we have some general statements initially, and the general statement we are trying to divide into some pieces of specific statements. So this is the deductive reasoning. Actually, many processes are there by which we implement this inductive or deductive reasoning. Now, as already I told regarding learning, what is learning actually? Now see, so it is the activity of gaining knowledge. See, obviously, once we learn something, we need to gain some knowledge or skill. How you will get it? You may be by studying, by practicing, it by being taught or experiencing something. So there are the few processes that you can be involved in the learning process. Obviously, learning enhances the awareness of the subjects of the study. So once you are learning something, at the end of the learning, our knowledge base should be updated. Only then learning will be completed, otherwise learning will not be completed. Okay, now let's see how many categories we have regarding this learning. So it may be auditory learning. What is auditory learning? So auditory means obviously once we learn something by listening or hearing, so that is belongs to the auditory learning. Episodic learning. So that means once you remember some sequence of events, okay, that is to learn by remembering sequence of events. As you know, maybe in maybe during Corona time, and again maybe few decades back, Ramayana, the Mahabharata, you have seen at that time those who are coming in TV shows. So that is episodic learning. That means some episodes are coming. Okay, so sequence of events are coming. So now we are experiencing us by this sequence of events actually. So obviously, episodic means that must be linear and thus that must follow some orders. That means the last episode, you should not start fast. The last episode, you should start before the next to last episode only, not before that. Anyway, what is motor learning? So motor learning means some movement kind of things will be there. It may be movement of muscles or it may be movement of other things. So by which we can enrich our knowledge base, that is belongs to the motor learning. So few other learnings are there. I'm not coming to this part. Observational learning, perceptual, relation, spatial, stimuli response learning, or many kind of learning processes are there. And as you know, that another important part of this is that problem solving. Once I am trying, we are making a system, AI-enabled system. So at the end of the day, obviously that system must have some problem solving capability. The system must have some decision-making capability. So that's why problem solving is very much important in almost all the AI-enabled machines. And once we are discussing regarding artificial intelligence, one most important keyword is perception. Often you will see during my sessions, I will utter this keyword perception. Actually, what is perception? So perception is the process acquiring, interpreting, selecting, or organizing sensory information. Whatever, simply I say that, okay, how you will feel that AI agent will perceive the environment. What do you mean by that? An AI agent is perceiving the environment. Environment means the nature where the AI agent is working. I am doing some statement. AI agent perceives the environment. That means AI agent visualizing, maybe acquiring, maybe interpreting, or trying to fetch some informations from the environment. Then only we should say that this is AI agent is perceiving the environment. And as you know, obviously perceptions, so presume sensing. And human, this perception is aided, perception is done by our sensory organs only. So we are the human beings. We have some sensory organs. We can complete the this perception process using our sensory organs. So what about the AI-enabled systems? What about the AI-enabled machines? How they will perceive the environment? Do you feel they have some sensory organs? Do you feel they have some like that eye, nose, ear, this skin like us? The AI system is having like that? Obviously, once we want to incorporate the human brain power to the system, then obviously we need to implement system also will feel some perception kind of information, some sensing kind of information. We need to implement that idea first. Only then the remaining things can be done. You're getting the fact. Perception is key term of any AI-enabled system. Because firstly, once you are keeping AI-enabled system in an environment, the system firstly need to perceive the environment. Only then it will respond to the environment, not before that. Firstly, you need to perceive. So idea is very clear. Once the AI system wants to perceive the environment, then that kind of sensory organs you need to implement in the AI systems. But obviously, we cannot implement similar kind of things, but we need to implement it in different manner. Otherwise, AI system can never respond to the environment. Now, linguistic intelligence, as you know, that linguistic intelligence is the key term actually. So it is our ability. So how we can speak, how we can interact, how we can comprehend. So so once you want a system to behave in similar manner, then you need to incorporate the linguistic intelligence also to these machines. So now we have discussed so many things regarding intelligence actually, regarding learning process. So what should be our motto? What should be our objective? What we should do to make a system intelligent? Now let us understand what will be the difference between human intelligence and machine intelligence. Can you differentiate? What do you mean by human intelligence? What do you mean by machine intelligence? So can I say that human intelligence actually how we can briefly define our intelligence? I should say this human intelligence here. Humans intelligence or simply humans perceive by patterns, whereas machine perceive by set of rules or data. Do you agree with me or not? I'll give you some examples. See, what is the difference? We are the human beings. We perceive by patterns. I think now the meaning of this keyword perception is very much clear for you. That's why I given that much stress on this keyword perception. Human perceives by pattern, whereas machine perceives by set of rules and data. Now see what is the difference. So can we implement that kind of features that also machines can perceive by patterns? I don't know. Research is going on that side. Human can store and recall information by patterns, but obviously machines do it by searching algorithms. The number is 40404040, 4 times 40. So this is the patterns we are remembering the number. But is it easy? That much easy for a machines to remember? So machines need to devise some rules. Initially starting from 4, once there is a 4, it will be immediately after 4, 1, 0. Once 0, 1, that immediately after then a 4. So some set of rules you need to define to remember the same thing for machines. Now see how much it is easier for human beings and how much it is going to be tough or going to be difficult for a particular system actually. And one thing more, so once that something is incomplete, suppose some figure is given and maybe some object is given to us and some part of the objects are broken or maybe incomplete. Easily we can assume what may be there. But how a system can assume what will be the missing part? Actually, that a lot more, as I was telling, number of research works are going on this side. Actually, that is mainly based on the uncertainty side. So uncertainty means, as you know, so once something is not clearly defined, something is not clearly given, something is not precisely given, imprecise informations are there, then what it will do? And as you know, you are incorporating a robot, okay, in some flood affected areas, where, how you will have some enough information regarding the areas. Entire areas went on flooding actually. How do you have the information? But the robot, that means AI intelligent machines need to work in that fashion, in that environment only, because that is very much risky for any human being. So you should implement them. Actually, it is very much easier for us it is that much easier, not that much easier for the intelligent systems. But again, obviously, intelligent systems should have the capability to work on the imprecise and uncertain environment also. And this is the various core research areas of AI. You have seen that I have kept artificial intelligence in between all these things: expert systems, neural network, robotics, fuzzy logic, natural language processing, and many more. So these are the key areas actually. So where now quickly actually we'll come to that AI agent actually. So once we are telling regarding artificial intelligence, so you should have a good knowledge on AI agent. What is AI agent? Artificially intelligent agent, agent is anything, as I was telling earlier, that can perceive from the environment through sensors and act upon the environment through effectors. Now see the situation. Agent will perceive the environment using the sensors. An agent will respond back to the environment, act on the environment using effectors. So if I say human agent, it is the example, human be agent, then can you tell me which are the sensors of human agent? It is very much easier. And which is the effectors of human agent? Obviously, our eyes, ears, nose, tongue, skin, all these are our sensors. And what is our effectors? So by which we are acting on the environment. That means it may be our hands, legs, mouth, all these things will work as an effector. If it is a robotic agent, then what will be the sensor? Yeah, now we are coming to the crucial part. Suppose our agent is a robot. If our agent is a robot, then what be the sensors for that particular robot? And what be the effectors for that robot? As you know already, so if it is a robotic agent, so obviously it may be some infrared range finders, maybe some sensors, some cameras, so that will act as sensors. And robot obviously will have some motors, actuators. So that will be motors, various kind of motors maybe the robot will having, so that may act as effectors. Okay, now what about software agent actually? What is the sensor and what is the effector for a software agent? So if software is agent, then obviously you need to have some keystrokes to feed forward some inputs. Okay, so these keystrokes, file content, maybe you can say sensory input. And once using the input, so you are displaying some output on the screens, so that may be your effectors. Now, as you say that when we can tell, one important question is there. When we can tell that an agent is an intelligent agent? How we can tell an agent be an intelligent agent? So we can tell that agent be an intelligent. So obviously, so if it is sensing the environment, okay, and it is doing the necessary, I think that is doing the necessary actions for the purpose of achieving the goal only, then we can say that agent is an intelligent agent. So many things are there on this part anyway. So now let me come to this part actually. As I said, that what is intelligent agent? So intelligent agent may learn from the environment to achieve their goal only. So, many once we are incorporating a robot in a flood affected areas, so robots should learn something now from the areas, from the environment, what kind of flood it is, what might be the various calamities. So obviously it should have some information. It should experience it with some information. Then only it can act, not before that. So that's why always our purpose or target will be that our agent should be intelligent, to make our agent as intelligent agent. And these are few rules that how we can make an agent intelligent. Now, these are few type of agents, obviously, that we need to discuss. We have some few types of agents. So first one is that simple reflex agent. No. So again, before that, what is an agent? So do you believe agent means only a software or agent means only a hardware? What is an agent? Is it that it is only a software or it is only a hardware? No. Agent means it is combination of both these things. It is combination of hardware and software. So agent means it is combination of architecture as well as agent program. What is architecture? Architecture means it is the machine on which that agent will execute. What is program? Obviously, this is the implementation of the agent function. Now, these are the few types of agent: simple reflex, model-based, goal-based, utility-based, and learning agent. So in simplest sense, I will try to explain what is simple reflex agent. If you go through any book, you will find out a number of things are written behind it, but I will not touch that part. In a very simplest sense, I will try to explain what is a simple reflex agent. Simple reflex agent, so it will work based on its current percept. Now see, listen to me. Simple reflex agent will work based on the current percept. What immediately I am getting some information, based on the information only I will respond. I will not respond based on my experience, based on my previously installed information. Simple reflex agent will respond based on the current percept only. Whatever currently it is getting from the environment, based on that only it will respond. So that is the simple reflex agent. Actually, there is a very fast agent that researchers has developed, that is the simple reflex agent. So obviously it will not act based on the perceived history. So it will not see what are the previous information you have collected from the environment. It will not take care. So do you feel that simple reflex agent is perfect agent for you? Do you feel simple reflex agent is a rational or intelligent agent for you? Can we employ simple reflex agent to do some work? Simply we cannot do. Then what is the need of it? Simple reflex only, it formed the foundation for the next agent. Once simple reflex agent came, simple reflex agent was developed, the researchers started to thinking, why not? We can implement, we can add previous percept, not only current percept. We should add previous percept, okay, to any AI-enabled system, to any agent. Actually, so that leads to the model-based agent. What model-based agent is doing? In model-based agent, so it maintains some buffer, it maintains some internal state. What the internal state is doing? Internal state is storing previous percept story also, not only the current percept. So it will store a sequence of percept, what it sent in the earlier times. Now you are getting the point. So model-based agents, how it is working. So it maintains internal state where not only the current percept, previous sequence of percepts are also there. Now you can tell. So which agent will work better? Model-based or simple reflex? Obviously, model-based will work much more better from the simple reflex agent, because it is maintaining an internal state. Now I can tell you that what is the difficulty with the model-based agent? What is the difficulty of this model-based? So do you ever seen that I have employed some goal to the model-based agent? Model-based agent may work based on the current percept, based on the previous percept, but it is not working towards achieving any goal. No goal is there in the model-based agent. So if there is no goal, then what is the need of that? As again I am telling, the researchers started thinking, no, along with the current percept, along with the previous percept, we need to add some goal in to the goal-based agent. So in goal-based agent, it besides whatever it is having in the model-based agent, it is having some goal information. That means what is the target? What is our target? So that goal is that it can work further to reach to the goal or to reach to the destinations. So that is the purpose of this goal-based agent. Now, can you tell what is the difficulty of the goal? We have done so many things. So slowly you are proceeding, starting from simple reflex, model-based, then you are coming to the goal-based. So what is the difficulty? What is the lackings in this goal-based agent? Goal-based agent is focusing only on the goal, but not which is the best route, which may be the best path to reach the goal. It is not focusing on that. Obviously, if you work on this goal-based agent, sometimes what will happen? You can reach to the destination, but it will take unnecessarily much more time. So that means, so we need to apply something on each and every path actually, because once you want to reach some goals from a source, number of paths may be there from the source to the destination, but which path will be cost effective for you? Who will identify it? Goal-based agent will not identify it. For that purpose, you need this utility-based agent. In utility-based agent, a specific measurement is that is utility. What is the function of this utility? So utility may mean, so it will measure the utility of each and every possible path. And it will take the path only where it will feel that optimum path. Now, are you getting the fact that means? So that means in goal-based agent, you need to add one extra more thing, that is utility. So see the second point, what I am writing, just check it very carefully. So utility-based agent based not only goals, it is not only focusing on the goals, but also it is focusing on the best way to achieve the goal. So that is the importance of this utility-based agent actually. We need to do that, we cannot bypass that now. What is the best way to achieve the goal? Okay, that means utility-based agent is much more powerful regarding that all previous models. Actually, this development is slowly starting with simple, then model, then researchers thought about goal-based, researchers thought about model-based. I should tell, yet it is not completed. Okay, fine. So utility-based agent, it may take the optimal path. Okay. But again, so how are you incorporating any thinking power, any learning power, learning capability in your utility-based agent? If your agent is unable to learn something from the experience, can it be successful? Is it possible that agent will be successful if it don't have the learning capability? So for that purpose, we need this learning agent actually. Learning agent, so extra learning capabilities there based on this all other things. So obviously once will employ some learning capability as well as all others capability, then only we can tell that AI agent is a complete agent. So see how the evolutions of agents took place actually, starting from simple reflex ultimately to this learning agent. Now, another important thing, that how you will measure the performance of an agent. I told you so many things regarding the agent, but how to measure the performance of an agent? Peers, simply we say that is the peers, peers. So peers is an agent representation system that helps to evaluate and define key aspects of an artificial intelligence system. Once you want to evaluate an artificial intelligence system, then you should know the peers information behind the system. If you know peers behind the system, then only you can evaluate the system. Now let us see what is peers. P stands for performance, E stands for environment, A stands for actuator, and S stands for sensor. Again, P, performance, E, environment, A, actuator, this is stands for these sensors. Now let us take some example actually. So actually what PIs will do? So PIs, it will help us to understand, okay, that what is the performance of that agent, which environment the agent is working, what are the various actuators environment that agent is having, what are the various sensors the agent is having. So it will give us a complete picture to evaluate the agent actually. Okay. Now, as I was telling, so let me tell you some example. Okay, so let me tell you some example of this. Okay, so now if I think we have some example of peers. Let me tell you that example, then I will come back to yeah. So let us see. So if we have some autonomous car be an agent, then what is the peers? What is the performance? How we can evaluate autonomous car? How much safe it is? How much time it is coming? How much efficient it is during the transportation. Peers. Now, what is the environment for this? your autonomous vehicle. Obviously, the roads, traffics, weather conditions, all these may be the environment for your autonomous car. Actuator actually. What is the actuator for your autonomous car? Actuator, obviously, it will be the steerings, brake, accelerators, lights, indicators, all may be the actuators for your autonomous car. And sensor means obviously you don't need to say camera, GPS, ultrasonic sensors. Car. Similarly, here I have given a number of examples for having this weird information. Okay, so let me come to that part. So as I was trying to convey regarding peers performance, so we should know that what is performance. Obviously, performance means it refers to the criteria, so by which we can determine how well AI agent, AI system is operating. So similarly, what is the environment? As I was mentioning, that I will tell you something regarding the environment. Here, environment for a self-driving car is given actually. So environment for a self-driving car, and so it may be the road, traffic, pedestrians, these buildings, weather conditions. Obviously, once a car is moving in an environment, mainly so it should take care regarding all those conditions. So already you know that what is access by agent will act or the agent will work on the environment. That we say that is the actuator. And if it is a self-driving car, obviously, how it is working on the environment, using the accelerator, using the brakes, using the gears. So all these will work as actuator. What is the sensors? As I told earlier, sensor means it will allow the agent to perceive the environment, to visualize, to interpret, to fetch some informations from the environment. That is the sensors. Sensor, so it is the devices, so by which the agent will perceive its environment. Okay, now let us see. So actually, as I was telling regarding these sensors, now let us see. So as already I told that example of peers. So let us see what is the advantage and what is the disadvantage of this peers in artificial intelligence. So if you have knowledge about this peers, so obviously you can break down an AI system, AI system into some understandable components by which you have a clear-cut knowledge that how the various components of the system is working. Obviously, you can get to know that. As I mentioned here very clearly, peers enables the replicability of an AI system easily. If you have the peers knowledge, obviously, maybe you will have the capability so that you can replicate the AI system, whatever you are getting. Now, what is the disadvantage of peers? Actually, peers informations are so simple information. That means if you have peers information again, but can you capture what is the complexity of the systems? Using peers information, it will never allow to capture complexity in the system. So that is particularly once you are using deep learning technique, so peers will be very much unfortunate actually. But again, as I was telling, so peers will be very much helpful in some other aspects. As I was telling that whatever we will discuss in the context of AI, ML, deep learning, once you will ask some tool, you will find out something will find out if he is having some advantage, at the same time it will give you some disadvantages also. Anyway, now let us quickly come that we had told so many things regarding the agent. Now, agent may work on the environment. So quickly, I'll briefly summarize regarding the environment. What may be the various types of environment where agent may act, where the agent may operate. Now, let us see. So before coming to the environment part, actually, I should mention one important fact that is called the Turing test. Turing test is very much important in the context of AI. Here, basically, why you do the Turing test? Turing test is done to check the capability of an AI-enabled system. So how to check that? Here, what you do? So here we will employ two persons and one machine. So mainly three things are there. Remember, I am employing here, incorporating two persons and one system. Out of the two persons, human beings, whatever I have adopted, so one person will play as the role of tester. Okay, and see, each of them sits in a different room. I have two human beings with me. One of them act as an agent tester and one machine with me. All of those three, that means two human beings and machines, all I am asking them or I am arranging to sit in a different rooms. Now see what will happen. That tester now is unaware actually. He don't know that in which rooms the machine is there, in which rooms that particular human being is there. Are you getting the fact? Tester have no knowledge in which room the machine is there and which room the human being is there. Then the tester will initiate some questions, texting some questions and sending both the machines and both that particular human being. Obviously, by which the tester will receive some response, some typed response. Now see. And by the response, if the tester is failed, unable to recognize which is machine, which is human being, then we can tell, okay, whatever the machines we have built up, that machines, obviously, that is an AI-enabled machine. Are you getting the fact? So that's why I was telling that Turing test is very much important to, I think, to identify the intelligent behavior of a system. See how nicely the test is getting done. Two human beings, one machine. All those are in different rooms. One human being is working as a tester. Since all those are sitting in different rooms, so the tester, what he is doing? So tester simply interrogating with the machines and with the human being by typing some questions. As a response, the tester is receiving some comments also, because some comments is sent by the machines, some comment is sent by the human beings. But at the end, if the tester is human being only, the person only. If the tester fails to recognize which room we have kept machines and which room our human being is there, if the tester fails to recognize something, then only we'll say, okay, so successfully we have incorporated intelligent behavior to our machine. That means our machine is now AI-enabled machine. So this is a very much important test actually in the context of artificial intelligence. Okay, now let us quickly come to the various environments of an AI agent actually. As I initially mentioned, agent means actually that where the artificial intelligent agent will work actually. So that is the environment. Now environment may be, various type of environments it may be there. Here I have mentioned one book actually, Russell and Norvig. So this is a big volume book, and what I have seen, this is one of the best book for this artificial intelligence. If you want to have some knowledge on this artificial intelligence, please refer to this book, Russell and Norvig, one of the most famous book. And here everything is written in very simple manner, so that if you read one time, you will forget never. Their write-up is like that only, very simple. Okay. So these are the various features. Environment may be fully observable, may be partially observable, static, dynamic, discrete, continuous. Many kind of environment you will face. Here I will narrate only few environments. Firstly, fully observable and partially observable. What do you mean by fully observable? What do you mean by partially observable? See. When an agent sensor is capable to sense or access the complete state of its agent at each point of time, then it is called fully observable environment. Suppose we are playing chess with our opponent. So can you observe the full system of the opponent or not? What the opponent is doing, what move the opponent is moving. Can you observe that, or it is hidden for you? Obviously, the thinking process or the purpose of the move is hidden. but you can see. It is completely visible, fully observable. You can see what moves your opponent is giving. So that is known as fully observable environment, where each and every step of an agent is known to us. Otherwise, we can say that is partially observable. And unobservable means what? When an agent has no sensors in all environments, it is a where zone actually. It is a fighting zone. Obviously, we have employed some agent, but the agent is trying to fetch the informations. But at the same time, it may have no informations also. If it is having some information, that is the partial. If it is a where zone, obviously, then we can say the environment is not fully observable. Better we should say it is partially observable environment in the case of a where zone. Here I have given two examples. One is chase, second one is driving. Okay, so once we are driving, then can you tell that this is fully observable or this is partially observable environment? Obviously, during the driving, we may face the environment is partially observable because we can view up to some extent. We cannot view the entire thing. Deterministic stochastic. Deterministic means, yes, see, that outcome of a particular action is determined by the current state and action. Remember what I am telling you. What is the outcome of an action? So you can determine it, you can find it by the current state and action. See, this is deterministic. That means simply you should remember no randomness is there, nothing random. Here it is given some initial conditions and actions, and the environment will produce same outcome. That means if you produce similar environment, similar actions, obviously each and every time your outcome will be similar outcome. No randomness is there in this deterministic kind of things. And what is stochastic? Stochastic means obviously that is random in nature. It is not unique actually, cannot be completely determined by the agent. So can you tell some example? Once we play some chess, so up to few possible moves, I can tell that chess is example of deterministic environment. Not all the moves, okay, only for few possible moves that the next move immediately can be determined. And what is the card game? Obviously, deck of cards, that is stochastic only, because that is random in nature. What is competitive and collaborative environment? So once you are playing chess, purely that is competitive. Once you are playing football, I am a part of my team, 11 players. Obviously, that is collaborative. We are collaborating with each other to defeat the opponent. So this is we are collaborating. Two opponents are playing chess. Obviously, that is competitive in nature. Single agent, multi-agent. Actually, that in real life, most of the cases you will find out it is multi-agent game only. Actually, Madam has requested me to deliver 2 more sessions. So probably there will be coming to the much more depth that of this AI. That one thing will be the adversarial search, where we will see that how multiple number of agents will interact with each other. Once it is a single agent fact, single agent game, single agent search, process is very simple. But once it is a multi-agent search, it is very difficult. That we will see at that time only. Today I am trying to skip that part actually. So another environment, it may be dynamic, it may be static. What is dynamic environment? No need to say. Dynamic means here environment will keep changing constantly with the time. See, environment that keeps constantly changing itself when the agent is up with some actions are said to be dynamic. Environment is changing only. Obviously, once we are driving a car, that belongs to the dynamic environment. An example is given roller coaster, obviously. Now, what is an idle environment? Static environment. No changes in its state. That is called static environment. I can tell an example. Empty house is in static, as there is no changes in the surroundings when an agent enters. Right? An house is the empty house. Agent is entering into the house. So every time agent will enter into the house, whatever the surrounding things, surroundings houses are there, obviously all times it will be static, fixed only. No changes on that part. Discrete continuous, that is very much important. Discrete, so that is purely coming from the mathematics part. If an agent consists of a number of actions that can be deliberated in the environment to obtain the output, so discrete. So discrete means finite number of actions, as you know. And if we say, game of chess, obviously it is discrete only because you are working on a finite number of moves. What is continuous? As you know, continuous, it cannot be numbered actually. The environment in which actions are performed cannot be numbered. That is not discrete and said to be continuous. Self-driving car, can you number something? So self-driving car is an example of continuous environment. Okay, and obviously once you are playing chess, so that is the part of this discrete environment. Finite number of moves you are having for this chess. So here again, many environments are there, known, unknown. So all I am actually just setting aside. Okay. Now let me quickly come to this another portions of this artificial intelligence. Let me take some water. Here, another important fact is their knowledge-based agent, actually, knowledge-based agent. So, as I was mentioning initially, that agent needs some knowledge about the real world, actually, to take some decisions or to initiate some actions. So, how it will capture the knowledge? Knowledge is a part of learning process. If we can imply some learning process, obviously, knowledge will be built up. So here our target is that to explore this knowledge-based agent, as I have mentioned here. So knowledge-based agents are those agents who have the capability of maintaining an internal state of knowledge. Obviously, once I am telling knowledge-based agent, so they should have an internal state of knowledge. Is not virtual now. Something should be there for knowledge. This is a big question. Sir, how we can represent the knowledge? Actually, in the knowledge base, it is a part of expert systems only. Knowledge base, we are representing the knowledge in using these if-then rules actually. If-else logic, C++ or Java, whatever program. So simply this if-then logic, applying this if-then logic, simply you are representing the knowledge using English language like sentences. That's why I'm mentioning here that knowledge-based agent, they need to maintain an internal state of knowledge. Not only maintaining the internal state of knowledge, they should reason about the knowledge. What do you mean by reason about the knowledge? They should cultivate their knowledge. They should nurture their knowledge. Maybe it is quite surprising. We are the human being. We can cultivate, we can nurture our knowledge. But how it is possible for an AI-enabled systems? Actually, this is one of the most, I think, difficult understanding. Here, I will give you some simple facts behind that how we can incorporate knowledge, how we can incorporate this nurturing or cultivation of knowledge in AI-enabled systems. Because we have some knowledge. Once we will capture, once we will nurture, once we will cultivate the knowledge. So based on the knowledge only, you will be getting some another knowledge. Our knowledge will be enriched. Knowledge base will be updated. Like we are the human beings only. The same things is happening in the AI-enabled machinery also. We are cultivating, we are nurturing our knowledge. Only then we are having some new knowledge. Similar manner, similar facts need to be incorporated in the AI-enabled machine also. One thing I told, how to capture the knowledge in AI-enabled agent. I told, knowledge will be there in the internal state, in the buffers, in using these if-then rules. In washing machine, what is the knowledge base? What kind of knowledge base may be there? Suppose if washing machine is your intelligent agent, or better I should say, washing machine be the example of knowledgeable agent. What will be the knowledge? How you will represent the knowledge in washing machine? I can tell you some example. If that apply more temperature, apply more cycle, and take more number of surf. apply more number of cycles and variation of the cycles. Now see, if I feel dirtiness heart is maybe cotton, again I will give in my knowledge base, I will put some different instruction. If dirtiness is less, type of clothes, fabric of clothes, apply variation A, let us say, apply cycle A, I have apply temperature level this. Now see how I am writing the rules in the knowledge base. So these are the rules only. So once we'll give some input, the rules will be fired. I will tell you the fact. The rules will be fired. Actually, in a knowledge-based system, maybe there, how the 10,000 number of rules may be there. Once we'll give some input, not all of the 1,000 number of rules will be fired. Only the rules which are relevant to your input, that will be fired. And some inferencing will happen so that it will lead to some upgradation of the knowledge base sometimes also. Okay, I hope you are getting. Now let me come to that part actually. Here it is written actually. So knowledge base are composed of two main parts. One is the knowledge base, second one is the inference system. So these are two components of our knowledge base agent. Now let us come to that part in detail actually. This is architecture of the knowledge base agent. See here. Here is the knowledge base. This is the inference engine. So this is the environment. See. Whatever the input a knowledgeable agent is getting, so all inputs are coming from the environment. Initially, it is processing through the inference engine. Now see. Inference engine is dealing with the knowledge base. Inference engine is pulling forward all the information to knowledge base. As I was telling, knowledge base number of rules are there. Based on the inputs, those specific rules will be fired. Some combination, something cultivation, something will happen in the knowledge base. That is the part of inferencing only. And ultimately, knowledge base will return that particular suitable actions to the inference engine. And inference based on these things, inference engine will produce the output. Now see, if I say type of clothes, if I say dirtiness is greasy, too much dirtiness, I will tell apply more temperature. One statement I am telling. Second statement I am telling that if number of clothes are more, I am telling number of clothes are less. Another statement I am doing. Number of clothes are less. Do less vibration, less cycling kind of things. And now see. Now here, if we add these two things, obviously your number of cycles should be more. So that means what I mean to say that some, all different set of permutation combinations, that kind of rules, it is not possible for anyone to keep in the knowledge base. So it is the part of training procedure only now. So once that knowledge base, once the inferencing systems will happen, the knowledge base also will be automatically upgraded. You need to upgrade. If knowledge is not updated, then what is the learning? Are you getting the fact now? If knowledge is not updated, then where you are implementing learning? As I was telling, that learning and knowledge, both of the two things should be a part, inherent part of your NI-enabled systems. Okay, so these all are the complex kind of things that slowly we are trying to discuss. So inferencing, as I was repeatedly telling, inference engine. What is inferencing? See, inference means deriving new sentence, new facts from the old facts. Try to get it. We have some old set of rules. From the old set of rules combining in various manner, we are deriving some new set of rules. Or we are firing the set of rules for the sake of our work. So that is the part of our inference engine. That is meant by inference actually. See what the second statement, inference system allow us to add new sentence to the knowledge base. Yes. So that is the learning process only. Inference system allow us to add new sentence to the knowledge base. And then if it is really happening, only then we can tell, okay, our AI agent now is capable of learning. Okay. Actually, how the inference system will work for two rules are there behind this inferencing actually, how inferencing will happen. So I'll try to tell mainly two things. One is forward chaining. See, inference system works mainly on two rules. One is the forward chaining, second one is the backward chaining. You may have heard that. Forward chaining and backward chaining, these two are the key components of any artificial intelligence system. Already you know what is inductive reasoning, what is deductive reasoning. And if you have understood inductive and deductive, so feel free, it is very much closer, very much similar to the inductive reasoning and to the deductive reasoning. So forward chaining and backward chaining. What is the importance of forward chaining and backward chaining? What you need to learn that? Can we avoid inferencing in your knowledge base? Once you are working with a knowledgeable agent, can we avoid inference system? You cannot avoid inference because inference is a part of your knowledge base system that will help you to acquire the learning phase, learning process, or that will help you to get the relevant output, which is your targeted output actually. So that is the part. Maybe I can tell that is the part of an intelligent agent, or that is the part of a rational agent. Okay. So let us see. As I was telling, that these forward chaining or backward chaining, these two systems that will utilize logical inferences to derive conclusions from the given data. See the situation. As an input, whatever you are getting. Once you are providing some input to the knowledge-based system, obviously you are providing some data, only raw data, you are providing some input. Now see. So raw data is given. And what is given? Some set of rules are given. So that means, so raw data is given and some set of rules are given. So now it is the responsibility of the inference engine or forward or backward chaining that you utilize the raw data as well as your set of rules to derive some new facts or to derive some new rules. Okay, now let me come to that part. Forward chaining and backward chaining. What is forward chaining? Let us see. Forward chaining, see, we are moving forward. That means forward chaining, see what it is doing. Here we are starting working with the simple facts. We are combining the facts, see. So starts with the simple facts and applies inference rules, see. Initially, in our hand, we have some simplest facts and we are applying the inference rules. What is our objective? To extract more data until the goal is reached. What is our goal? Washing machine. Our goal is so that our whatever the clothes we have provided to the washing machines, so it should be without damaging the clothes, okay, so that no damage should be there once the cycling process or the cleaning process is going on. But yes, cleaning process should be optimized. We will get much more clean clothes. We entered the dirty clothes. As a result, we are getting clean clothes. So what is happening there? Obviously, some intelligent kind of things are happening there, where we are not interacting at all. Now see the system actually. So we are starting with the simple data, simple fact, applying some inference rules. Ultimately, we are getting to extract more data unless the goal is reached. Now let us see what it is doing. Actually, firstly I will tell for what is the forward chaining only. What forward chaining is doing. So forward chain, I say, so this is the data-driven approach actually, data-driven inference technique. Data-driven means what? It will start with the data. Ultimately, it is reaching to the goal. If you can think about a tree, you know, in a tree, top root is there. And once you come down to the tree, you will find out all the branches, finally all the leaves will be there. Root node and leaf nodes. Root node at top, leaf nodes will be at bottom part of that tree. So in a forward chaining, we are starting with the leaf nodes. Here you can consider what are the branches we have now. That branches here, if we can write a tree like that, suppose I'm writing this is the root node and this is all my the intermediate nodes, and this is the suppose this is our leaf node. Let us say this is our leaf node. Okay, this is our leaf node. So here this is our leaf node, this is our root node. So what is our target? So this I can tell. So this is the goal. and I can tell, so this is our data. So in the leaf node, we are providing the data. And whatever the various branches like the edges, so these edges are nothing but the inference rules. Okay, we are starting with the data. Obviously, you may start, suppose I am starting with these two data. So then maybe this rule will be fired, this rule will be fired. Based on that, I will get some conclusion, this data. Like that, I will proceed to the top actually. See, so forward chaining, I say, so this is a bottom-up approach actually. Starting with the facts, utilizing the inference rules, whatever necessary, it is moving towards the goal. Data-driven technique starts with the available data and applies rules to inference new data until unless the goal is reached. As I was telling, is it possible for any of the systems to incorporate all possible rules? Is it ever possible? Because you don't know even what might be the various rules that a problem will face. How we can incorporate all the rules as inference, as a part of inference systems? Okay, we may apply some simple set of rules. The system should have the capability to learn itself now. Learn means based on the old rules, based on the provided data, it will update the knowledge base, it will reduce the new rules. That must be the case for any AI-enabled systems. Okay. So now you are getting it. So this is our forward chaining. So what is our background? How forward chaining is working actually? As I was telling earlier, it will start with the known facts. It will apply the rules. It will infer the new facts. It will repeat the process until unless the goal is reached. Now see the working flow. See, start with the facts. It looks for the rules whose conditions are satisfied by the facts. I hope you are getting. So this is a very much critical concept. I'm trying my best to deliver so that you can understand it. Infer new facts. When a rule is applied, obviously new facts are inferred. Until unless we repeat to the goal, we need to we reach to the goal. Maybe we need to repeat it. Okay, this is the forward chaining flowchart. See, so these are the facts. Okay, some things, decisions, and these are the inference rules only, na. And this is maybe the composition of rules. Sometimes and you need to apply it. Sometimes or these are the rule compositions, because sometimes we need to combine the rules also now. Once one rule is not sufficient, then we need to combine multiple number of rules. Maybe by which you are getting these decisions. Now see, again you need to combine. Maybe you will get these decisions. Again you need to combine. You will get final decision. Are you getting? So this is the updations actually you are getting. So see, it is deriving to some new facts. It is deriving to some new rules. This is quick example I am giving for this forward chaining. So if the patient has fever, see, fact. So this is the fact. Patient has fever. What is the rule? If the patient has fever and rash, they might have measles. Now see here. What is the known fact here? Fever. Now the system will check for other symptoms, rash. So if the patient has also rash, then system will infer possibility of measles. But if the patient don't have any rash, then what the system will do? System will tell that no, that patient is not suffering from measles. But is that rule is given in the system? The rule is not given in the system. Rule will be simply updated. Now, what is backward chaining? What is forward? Forward chaining already we have discussed. Now, forward chaining will flow a very fast search, BFS technique. It will flow a BFS technique. You know, in BFS, what will happen? What is happening in BFS? BFS, it is proceeding branch-wise, level-wise, not branch-wise, level-wise. Each and every level, possibility is there that each and every level, all nodes will be visited in case of this brain fast search. And what is the DFS? In DFS, it is coming depth-wise now. In each and every level, all nodes may not be visited in depth first search. But in breadth first search, each and every level possibility is there, all nodes will be presented. And forward chaining, obviously, it follows this breadth first search. That's why complexity or time consuming is more here. Okay, now let us quickly come to this. What is backward chaining? Backward chaining another strategy, which is just opposite of forward chaining. That means what? It will start with the end goal, and ultimately it will work backward through AI rules to find the facts that support the goal. Are you getting? Backward chaining, it will start with the goal. Based on the inference rules, what it will try to do. So based on the inference rule, it will try to derive the fact. Just opposite of this forward chaining. Let's see. So what is backward chaining, as I told. So backward chaining actually. So it starts from the goal. It starts from the goal and then slowly coming back to the data. Okay, so you see that. So now let us see the situation. So see, this is our decision. So starting from the goal and it is deriving the data. So this is another process of inferencing. Starting from goal. So using the set of inference rule, how it is deriving the basic data. How much wonderful it is. You have the goal. This is very much like our explainable artificial intelligence. So we are having the goal. So based on the goal, using the process, using the inference logic, whatever you have, it is trying to derive the facts. You see how much powerful it is actually. Backward chaining, we say it is a top-down strategy. You can remember once I have drawn that tree. So I told that forward chaining starting from the leaf, moving to the root. Backward chaining start with the root, it is moving to the leaves. It is modus Fanon reasoning. Actually, a number of reasoning is there. Modus Tolen. So that if I get some time, obviously, we'll come to that. So it is a goal-driven strategy. So forward chaining is a data-driven strategy, whereas backward chaining is a goal-driven strategy. Goal, that means here we are starting with the goal. From the goal only we are trying to derive the fact actually. So these are the algorithms for this backward chaining. Okay. Now this is some example of backward chaining. And now here I will tell you something here. That's what I am for the right moment I am avoiding. Okay. Now, what is the advantages and what is the disadvantages of this forward chaining and backward chaining? Actually, let us see. What is the advantages of this forward chaining and backward chaining? For forward chaining, you can find it is very much simple. Data processing, comprehensive, it is very much efficient. But what is the difficulty of this forward chaining? It is inefficient for this goal-oriented task. It can be inefficient if an only specific goal is needed to be achieved. Whereas it may generate many irrelevant inferences. Yes or no? It is working as BFS only now, starting with the leaf nodes, or necessarily it may inference a number of rules, whatever may not be necessary. Memory intensive because it is using BFS, it will try each and every level, it will try to utilize each and every rule actually. Now for backward chaining, what is the advantages of this backward chaining? See, here the backward chaining, so see, begins by developing a hypothesis and afterwards determining whether or not it can be proven. Hypothesis it is taking. So once it is starting from the goal. And then it is trying its best to prove, yes, we can prove the hypothesis or not. So it is concentrated on a specific objective. Only employs part of the knowledge base that are pertinent to the hypothesis. Are you getting it? It is a top-down approach. It is a DFS, depth first search. So each and every nodes, each and every knowledge, each and every branches no need to explore. Whatever is necessary, only that we will explore. Okay, just give me 5 minutes. Just I will be coming back. I will not take so much time. Within 5:15 we will close. Just please give me 5 minutes time and come back.
Sir, it's over, sir. Sujit, sir. Hello. Sir, you are not audible now.
Madam, sir has taken a break for 5 minutes.
Okay, sir. Okay.
Yes, so once again, we are in the session. Okay, so that's what I was discussing. Now, what is the difference between this forward chaining and backward chaining? So, a number of difference here we can tell that we know that forward chaining here, that is a data-driven approach starting with the data, and I can tell that backward chaining, that is a goal-driven approach starting from the goal. Forward chaining is BFS, follows BFS structure, breadth first search, whereas backward chaining, it is following BFS. So, like as you know, a number of differences we can identify between this forward chaining and this backward chaining. So, forward chaining is starting with a forward chaining. We can tell this is a bottom-up approach. If we consider a tree, so forward chaining starting with the facts, with the leaves of the tree, slowly trying to move towards the goal, towards the root of the tree. Whereas in backward chaining, so it is starting. It is actually top-down approach, starting from the top, slowly coming towards the down. Forward chaining is bottom up, whereas backward chaining is top down approach, starting with the goal, and from the goal, based on the inference rules. So it is slowly it is trying to get the facts which are there working behind the goals. So, like as a number of difference we can discuss. Okay. Now, quickly we'll come to the part actually logical reasoning. So here, number of rules are there for the time being. I'll avoid. Now, one important thing is there in artificial intelligence, that is the propositional logic. As I was telling, I think sometimes back that I told so many things regarding the rules. Actually, how to represent the rules. Okay, how to write down or how to note down the rules. A number of facts are there. So here we will try to highlight on that part. So one of the important thing behind that is propositional logic in artificial intelligence. What is a proposition? So proposition means, once you are telling some statements, once it is either true or false, so that we can tell that true means it is tautology, and which may be false. Contradiction. False means contradiction. So statement, which is either true or false, nothing is in between. Then it is with actually this concept, propositional logic or first order logic, we need to represent our knowledge base actually. Without knowing the concept, it is very much difficult to represent the knowledge. So here, if I say that today is Wednesday, it is true or false. Okay, 3 plus 3 equal to 7, true or false. 5 is a prime number, true or false. See, whatever statements I have written here, only we can tell that is true, either that may be true or that may be false. So that is the part of proposition. So as I was telling, so propositional logic. So that means sometimes we can tell this is a Boolean logic also, and it works on 0 and 1. It may be either 0 or it may be 1. Now this propositional logic, whatever we have, we can use some different connectives. As you can recall that sometimes back I was telling whatever the rules you have in the knowledge base, sometimes you need to have a composure of 2 rules also. That means you need to apply some logical connectives on the set of rules actually to combine the rules. So like that here, proposition also, we can use the concept of connectives so that we can combine 2 or multiple number of propositions. Okay. Now, this CC propositions can be of 2 types, as I was telling. One is atomic proposition, single statement. Second one is called compound proposition, where multiple number of statements will come inside this compound proposition. Atomic, so it consists of a single proposition symbol only. So these sentences I must be either true or false. If I say 2 plus 2 equal to 4, okay, sun is cold, whatever you may say, true or false, that means, so these are part of atomic. Now what is compound? Compound means, so that must be compound propositions, here we need to build up them by combining these 2 or multiple number of this atomic proposition, and at the same time you need to apply the concept of connectives or parentheses for the purpose of combining. So here we have given some example. So it is raining today. So see that this is one part, one proposition. The street is wet, different proposition. How we are combining using the AND logic. So it is raining today and the street is wet. So this is a part of this compound propositions. Okay. Many things are there, simply for that I will avoid. Now, what are the limitations of propositional logic? Is it possible to represent each and everything in this world or in this universe using this true or false? Is it possible there? If I say all kids are intelligent, this kind of statement. If I say some apples are sweet, what will be your conclusion? Can you mark them as true or false? We are helpless here. We cannot do anything. Because some kind of situations are there which is beyond of representation using either true or false. Like all, once we are using this keyword all, some, none, with the propositional logic, then obviously their propositional logic is finding very helpless to represent or to present these kind of ideas. But these kind of ideas are very common in our real life. Then how to represent this kind of ideas? To represent this kind of ideas, we need this first order logic actually. So this is the limitation of this propositional logic. It has some limited expressive power. Once this kind of situation will be there, all, some, none, there exists something else. So then propositional logic, using propositional logic, it is very much difficult to represent those situations. Then we need some another concept. So that concept is known as this first order logic actually. So propositional logic, we cannot describe statements in terms of their properties or logical relationships. So we need something another that is called first order logic. No, how so in first order logic, what we are doing? So where actually the propositional logic fails, first order logic just starts working from there only. If I say some humans are intelligent, obviously here we will fail to represent it using propositional logic. It is not a tautology, it is not a contradiction. Then we need to have some other kind of mechanism, we can say in terms of this first order logic, to represent this kind of situation. See, now once we are working with first order logic, actually once you will see the knowledge base now. So most of the cases, I think few slides back also you are checking some slides I skipped at the time. That was full, I think, packed with this first order logic. That's why I skipped it at that time. So this first order logic is also known. This is a predicate logic or this first order predicate logic. Now see here, first order logic, actually few things are there: object, a relation, functions. So these are some tools, particularly those which will be using once will be representing a fact using this our first order logic or FOL. Okay. Now let us see. So now some example of first order logic. So once we have some, this is some rules actually. Once we have some constant, then you need to use this symbol, variables, this symbol, predicates using this. Okay. And these are some connectives. Actually, you are using quantifier. This quantifier is for all. And this quantifier you are using, there exists something. Okay, let us come to that part. See here how we are doing that. So if I write Robbie and Ajoy are brothers. Okay, so suppose this is our rule, and this rule we want to write using the first order logic in our knowledge base. So how to write these rules using first order logic? So simply if we write this brother, so this is a function, remember. So this is a function. Okay, now these are subjects, Robbie and Ajoy. See, now this. Chinky is a cat. So this here, if we see this cat, then Chinky. So a number of rules are there that how we can use. So here I will show some example. Again, check. Actually, two things are there. One is, as I was telling, this is called universal quantifiers. One is universal quantifier, where you will use these kind of things for all, everyone, everything. And second one is existential quantifiers. For some, at least one, we can use that. Universal quantifier, suppose here I am writing one thing. All men drink coffee. Okay, see. If x is a variable, then if we write this for all x, how we can read? All we know by using mathematics, it means that for all x, for each x, for every x, like that. And one important signal, it is that implied. So once we'll apply this symbol, so this symbol means it is implies. Okay, let us see. All men drink coffee. So this is a statement. So obviously this statement we cannot represent either tautology or contradiction. Then we need to imply our propositional, our first order logic for that. And since all this keyword is there, obviously we can use this universal quantifier for. Now see, can we represent in this manner? For all x, man x implies. So if that means this is implied. Implied means if this is true, then that also will be true. So for all x, if x is a man, then also this man drinks coffee. See, here x drinks coffee, where x is a man. For all x, man x. That means for all x, where x is a man, this x will drink. So this is the manner actually that we represent this complex, I think, ideas using this first order logic. So this is an example of universal quantifier. Another example is that is called existential quantifiers. So here we will be using this symbol, they are exist actually. So if we say some boys are intelligent, so how to do that? See that there exists x. Okay, where x is a boy and x is an intelligent. So number of ways are there you can represent. This is one of the way that we can represent these ideas using this propositional logic, as I was telling. So how it is important over this simply propositional logic. So here we can read it. There are some x where x is a boy who is intelligent, as I was telling. there exists some X, where X is a boy. At the same time, X is intelligent. So that means here we mean to say that some boys are intelligent. So again, many things are there. So that simply I'll try to avoid. So another interesting things was there, one password problem in artificial intelligence. Actually, this is something different topic. So we'll try to cover in maybe in our next session. We'll not cover the cover of this today, but this is very much important one. So that will be maybe help us to understand some other topics. Anyway, so we have some 5 minutes time left, as I have taken permission from the coordinators that I will continue up to 5:15 actually. So now this session is totally open for question answers. So if you have any questions, you can ask. So mainly what I targeted today, since this is the first session of artificial intelligence, so I was trying to tell you that some fundamental ideas from this artificial intelligence, actually those are mainly related to this intelligent agent concept actually. Once we make some intelligent agent, then what are the various things behind that? Or how to make a system as intelligent system or a machine as intelligent machine? What are the various knowledge you should be aware about that? Simply, I was trying to narrate it down, all these ideas in very simplest manner. As you know, AI is a huge subject actually. So I have, maybe I have 2 more sessions where I will be telling most interesting things of AI, that is probabilistic reasoning in AI. That is another different directions. Today, we all are working on particularly on expert system sides, totally on artificial agent or intelligent agent side. So there we will see some different angles actually, how probability is getting helpful, or what is the role of probability towards decision making using artificial intelligence. That is called probabilistic reasoning in artificial intelligence. We have 1 more session where maybe we'll be delivering that. Today I actually avoided that part, that adversarial search actually. That day I will tell you some other search algorithms also, as well as adversarial search. Today you have seen that agent may be single agent may be multiple number of agents. Now today I have not discussed anything once multiple number of agents are playing against each other. Suppose I am be an agent, Manjubala madam be another artificial agent. So I am playing against Manjubala madam. That means my objective is to maximize something. Where Manjubala madam is trying to minimize the same thing. I am trying to maximize my profit. Madam is trying to do the reverse thing. So that is conflicting in each other. That means here 2 artificial agents, they are competing with each other actually. Then what will be the outcome? This is called a game actually. So this is called adversarial search. That means it is a multiple number of agents, multiple agents games when they are playing against each other, along with the conflicting goals. Then what will be the situations? So that is another directions of artificial intelligence. As you know, so it has many other directions. So today I hope that we will be getting some fundamental ideas wherever I was trying to maximize my focus, particularly on this agent size, intelligent agent size, and particularly on this what is the knowledge base, what is the expert systems, how knowledge base may be updated, what are the forward backward reasoning, forward backward chaining, inductive deductive reasoning. On these sides I was trying to focus. I hope that may be helpful or for you. So for the, I think this is the starting. You need to go for along with so many sessions. Maybe that will be helpful to understand the concepts of these remaining sessions. Now, if you have any quick questions, obviously I am ready to take your questions, as well as you can type in chat box. Also, please note I have given my contact number as well as my email ID. So remember it. This is my WhatsApp number also. So that means if you have any queries in future, or any of the participants want to carry on any collaborative work with us, so please drop me an email, or please drop me a WhatsApp message so that we can contact with you. Now, if you have any quick questions, we'll take. Otherwise, probably madam may be waiting. So I need to close the session. If you have any quick question, I will be ready to answer your questions. So let me check. Let me check the chat box, so if it's right or not. Okay, I feel that maybe complexity of the session is that much. So that means, anyway, I hope again this session will lead to some questions in next two of my sessions. That obviously I'll be expecting for some questions from you. Okay, if there is any questions, we will wait. Otherwise, simply I will hand over the sessions to Professor Manjubala, madam.
Yes, any questions from the participant side?
Obviously, we will share the slides with our coordinators, so you can collect the slides with your coordinators. After the end of this FDP, successful completion of this FDP, we'll be sharing everything.
At the end of the FDP only, we will share everything, not now.
Yes, only after the closure of this FDP.
Okay.